Welcome. This is the last session that we are having in this training program. But of course, our association will still continue. Our relationship will still continue. That's not stopping here at all. But as far as the structure that we had, this one is the last topic, last session that we are having. Uh, and this is the topic which is very important again. This one is not a very specific area of the APIs, category of APIs that we are going to look, but this is something which is uh, the extension to the uh, base programming topics that we have seen already. So we have seen what can be done to write the best code. The code should be self-explanatory. The code should be simple to read. The code logic should be easy to understand. It helps you uh, spend less time in documentation and again lot of other benefits following the best practices that I have shared. Now we are going to talk about uh, actually, it is not extension to the best practices, I would say, but it comes a little bit prior to the best practices because we are going to talk about how you deal with the errors. By this time, you have done so many examples, assignments, I mean, and during those assignments, you have come across some or other error. Your code is not working, some error has been thrown and you don't able to understand the meaning of that error. So you have gone through that experience already. We haven't seen or we haven't really touched upon how to handle those errors except a few situations where I have explained you something about those errors, tackling those errors, but not really that much. So today's topic is error handling. uh, those are also called exceptions, and how you can tackle those exceptions, how you can avoid those exceptions. We'll also see the uh, we'll also see the examples, and we'll also see how you can, what methods you can use, what are the ways to avoid getting into the errors. Because I already shared with you the best practice. When you are following best practice and you are writing a code, your code should be world class. It should be a like a pro programmer code that does not fail, that does not provide any errors. Of course, it is a very tough job to do because anything that you use, maybe any app on mobile, any application on your system, any website that you are referring, we many times come across the errors, even if it is a very well trusted software, well trusted app we are using, still we can experience something which is not expected. But still, our aim should be that we shall minimize the errors close to zero. So this is what we shall aim for, and this is where we need to understand how to handle errors. So there are various angles to handling errors. Few of them we will touch today. So we'll start with exception. Now, what is exception? Uh, you have a code, and that code encounters a situation that cannot be handled by your uh, whether it is code, whether it is NX. So it is not handled by, it is beyond the capacity of NX to handle that, or beyond the calculation capacity of that program. So processing capacity, you can say. For example, we wanted to create the extrude, and extrude we can create, let's say we wanted to create the extrude across y axis. It means that my sketch should be on zx axis, sorry, zx plane, right? Then and then only I can extrude it along y. But if my sketch is along XY plane, then I cannot extrude it across Y, right? And this is where we are giving conflicting inputs. We have returned the extrude builder, and this is what our inputs are. And then these are the conflicting inputs. Our NX session cannot create the extrude feature with that conflicting inputs. So this is called the situation. This is something, the situation that cannot be handled. Just a typical example. So this error condition that occurs because of conflict in our code itself. What we are doing, we are providing some input uh, through the code to the computer to create that stuff, and that is conflicting, that is not correct, and then code encounters an error. That is called exception. So when you see a pop-up error message on your screen, it means that this is something, that is the condition that cannot be handled, and the system has thrown that exception to us. The other example is that we are using some calculation that is divided by 0, and we are using that as an input for creating geometry. For example, start angle, end angle, both are 0, or it is a infinite. You are using some calculation, and it is infinite because it is divided by 0. So that time again, similar situation will come. It is also an exception. The another situation where this exception happens is we wanted to convert the data type from one type to another. Let's say we do have a string, which is the uh, uh, some word, some text, and we wanted to convert that text into integer or double or boolean. So that is not possible, which is very obvious. We cannot convert the data type like this. We can convert the integer into string. We can convert double value into string. But other way around, it is not possible, because that way the conversion not happens. And then if we are trying to do something like this, then we also get an exception. So you might have seen it is not possible to implicitly convert this data type to that data type. So that is called uh, the exception. And many times we also got the exception related to object not found. Object is null. So I am not going to give you the examples around this. As you have practiced a lot of assignments, I am sure that you have come across this already. But if not, you have done that much. But if you do it now, then you will definitely come across this, because this is something that you are not yet uh, aware of that much. So definitely you are going to come across these many different error situations, and these all are because of the some condition that cannot be handled by program, and that is called exception. Now there are different types of exceptions. Again, we are not going to go into that much of details, but broadly there are two kinds of exception we can see. One is system exception. It means divided by 0, that is system related processing happened, and system handles that kind of processing, and then it is not possible to do that, then it is called system exception. But the first example that I told you, we wanted to create extrude along Y, and our sketch is also on XY plane. So that is the exception within NX. So that is called NX exception. So it is very simple. So this is very broad category. If it is the exception outside NX, that is called system exception. If it is due to some conflicting inputs that we have given for the object creation, or for whatever we are doing into NX using NX APIs, and if that exception occurs within NX, that is called NX exception. Now, uh, now let's take some example, and through that example, we will understand. about the exceptions more. Let me share my screen. Mm, I think I will show you that code inside Visual Studio. Let me open my Visual Studio. We are going to see the example around NX exception. Okay, so this is the typical example. This creates arc, and we do have all the parameters defined to create the arc, and then create arc API is used. All those parameters are given, and this shall create the arc. Now, what is new here? What is different you can see in this code? So I'm talking about the one of the way to handle the exception. Now, for now, I will remove these lines. Those are actually one of the way to handle the exception. Here, simply I have given the parameters radius, angle 1, angle 2, start angle, end angle, then center point, then y direction and x direction. And I have uh, created the arc. Now I will copy this code. We will execute this code into NX, and let's play this. Now you could see I have got this message: journal execution error, NX open dot NX exception. So this is the NX exception, and we do have got some information about that error. Illegal arc length specified, and we do have a detailed description about that. So uh, as an Open developer, we must understand this error, but we do not expect user who is using our program shall also understand it. So he is actually uh, not aware about anything related to NX or related to programming. So we don't expect that he also understands why this error is coming. But we, as a programmer, we must know that why this error is coming, or at least we have to try to understand the reason behind this error. So, and there is lot of information that we get in this kind of messages. So you can even see that we got the line number even. So it is our job to find out why this error is coming. We have to find out the root cause for that error. And if we found the root cause, then we also know what changes we can make to our program so that this error will not come. So finding out the root cause is very important to handle the errors, handle the exceptions. If you are not able to find out the root cause, you won't be able to fix it. It is as simple as that. So we have to find out the reason for that, and we can go and fix it. Okay. Uh, so there is one way to handle this exception. That is what we are going to see now. The exception, how we can handle it. Now let's assume that I don't know the reason for this exception. Even I do not have a control on whether I can whether I can remove this error or not. I don't have any control on that. So in that situation, what we do, we can use try catch method. Try catch is used to catch the exception. And what is going to happen with try catch is, anyway, whatever is the error, whatever is the situation where that process cannot happen, a try catch is not going to help resolve that error. But what will happen with try catch? Try catch will bypass the error. Means it will, we are actually suppressing that error. We are not showing that error to user because it gives a wrong impression. Instead, we will just mute that error, but the program will not execute that specific process. So this is what happens with try catch. So with this, you can understand try catch is not the best way to use when uh, uh, try catch is not the best way to use, but if it is something which is beyond your control, it means that it is purely depend on the user. User is giving you the lot of inputs for your program. That time you do not have any control on the inputs. So maybe if he gives some conflicting inputs, so that time your program may go wrong, and this is how you do not have any control on your own program. That time you use try catch, then you avoid giving some wrong errors to him. Otherwise you can modify that error message. Instead of some message that user may not able to understand, you provide some meaningful uh, message to him. So that is called try catch. So try, and then this syntax is used for try catch, but it is not that it is not complete. We have to also mention catch. Try and then catch. So this is a simple syntax, or this is a simple format for using try catch. So try catch is a C# function. Try means what? I'm mentioning that you try creating a curve. I'm mentioning to my program that you try creating a curve, and if any exception has got, then just catch that exception. Instead of showing that to a user, we can catch that exception. If it means that I'm just giving him uh, like an option. So uh, if I'm not using try catch, it means it is a mandatory that it will execute that code, and it will try to complete that process, whatever the automation task that I have written into my program. So that will, my program will try to finish that. But try means is that I'm not mandatorily giving that to the program, or means I'm keeping it optional. So try, if you manage to create the arc, create it. If you not, then just catch that as exception. So this is what is meaning of try catch. Okay, now let me copy the complete syntax of try catch, and we can study that. Okay, so try, and within bracket whatever written here, this is the create arc line. So try creating arc and catch if you got the exception. If the exception is got, then catch that exception. I knew that as I am using the API, which is NX Open API I am using. So I'm sure that if this is not working, then obviously it will be a NX exception. It is not going to be the system exception. So I have used NX exception in catch, and exception means what? It actually throws that exception, and it also gets the error message. So whatever error message we have seen in that pop-up uh, box, so that same message is captured in this catch. So the same message is captured. Now I do have a choice. I can show that message to the user, or I can keep showing that message to the user. Instead, I can show some other message. I can bypass this message and I can show some other message like this, which can be much meaningful for user to see. Okay, if I know that probable situation is like this, that there can be the zero values used for radius or angle, and then that time create arc won't be possible, and that time this exception will come. So if I know this is something that can happen, then I can write some meaningful message to the user. The user understands that there is something wrong with the inputs given. Instead of giving some technical message which user may not able to understand, it makes sense giving him a message that is meaningful and he also able to understand it very well. So this is the message that I wanted to provide. So try catch helps me catch that exception, mute that warning message, and pass on some other message that gives meaningful information to the user. This is what is happening with try catch. Now let's run the same example in NX. Now you can see we got the same thing. Now this time we have chosen to show that message into the info window. Now you can see along with all that standard exception text, this message that we got earlier as a pop-up window. So this is what we got as a standard. But along with that, we also get check the values used. Make sure that radius or end angle value is not 0. So this is what we got. Even I can mute this ex. Ex is nothing but the variable, and this variable has the error message that has caught by catch function. Uh, an exception has occurred, and that is cached in this catch function, and that is the string or the text of that message is captured in this ex variable. So this is variable. Ex is a identifier name, and the type is NX exception. So I'm using toString to convert that into string so that I can show it in the information window. So let's say I do not want to show that information window. Uh, I do not want to show that exception message. Instead, I wanted to show only this meaningful message to the user. So I can go and uh, show that message only. You can see now this makes this is much more uh, easier or much more comfortable for user to see. It gives a meaningful message, and then user can go and check his inputs, and then he can perform the run the code again. Okay, now this is just one method that helps us catch the exception, and we can uh, handle that exception, not handle actually, but we can mute that exception and provide some meaningful message to the user. But it is more advisable in this kind of situation, whether if we are capable to handle that that situation, and if we able to see that it is not it cannot it sorry if we manage to remove that situation. Means our code should not go into that situation. If we manage to avoid that situation, then which is much more uh, uh, what I can say, which is much more uh, recommended thing to do, right? It is much more recommended thing to do. Now I'm getting this message, which is very meaningful. But if I know that this is the reason that angle is zero, and this is why, that is why it is happening, then it makes sense that I make the correction, required correction, and then I run this code. Then that time it will not, the exception will not come. So it makes sense that we try to see that our code is not getting into the exception. So this is our first priority. If there is something we cannot have a control, that time you can use the try catch and catch that exception, and we avoid doing that operation, and but also provide some meaningful info, message to the user. Now I do have another example which is much more better than this one. So let's see that. It is the same example, but it is much more better written, or I would say it is, the exception is much better, uh, is handled in much better way. The same example, uh, you can see we do have a try catch, but within try catch I do have one condition, if condition. So what I'm checking here, if user gives some wrong input, wrong value, radius is given as 0 or angle is given as 0, then uh, my program is not going to work. Create arc is not going to happen. So it makes sense that even if I use try catch, or not, I must use, I must validate those inputs. So this is the if condition that is ensuring whether my inputs are correct or not. So I'm ensuring that radius is not 0, angle is not 0. If these two things are not 0, then I'm sure that I'm going to have the arc created. And then if it is, this condition is met, these parameters are not 0, then I'm much more confident that my program will work and arc object is created. So this is much more recommended approach to follow. What we are doing here is we are avoiding our program to get into exception. So this way, whatever all those exceptions that we can foresee based on the what our program is doing, we can add if condition. We can have checks at each point and each step, and then we can write the code related to that checks. And this is how we can avoid our code going into the exception. Similarly, I can even check for the axis. So I'm mentioning it is x-axis. This one is y-axis. So it means that uh, the x coordinate value for x-axis should be 1. It cannot be other value. It cannot be 0.5. It cannot be 0. So I can also use the if condition to check that. That can also the additional check that I can perform. Similar to axis y coordinate for this vector 3D should be 1. If it is not, then it is not going to work. So that checks I can, so lot of checks maybe I require to add, but there is no harm adding that many checks. We can go and add that many checks to ensure that our program is not going to fail in any situation. So this is if condition, it checks this condition and based on that arc is created. But if this condition is not met, it means that there is either radius is 0 or angle is 0. Then that time we do have else, and if else means we are giving the message to the user. We are not going to create the arc if the values are 0. Instead, we will give this as a message to the user. So let's try this example. Yeah, so it is the same example here. Now if I play this journal, so this is not an exception. So I'm telling user that this is not an exception because I have checked some values and I found that those values are 0, and that's why this exception is coming. And this is very well uh, captured because of this if condition. So this is a check before creating arc. Check the values used. Make sure that radius angle values are not 0. So I am giving a meaningful information because I have added some specific checks, and based on that specific check I am able to give some meaningful information about the error or about why that process is not happened to the user. So this is what is called error handling, and these are the just couple of ways to do that. One is adding try catch, but try catch is only recommended when we do not have any control on how we add sorry we do not have any control on the exception. So that time using try catch makes sense. But if we do have a control, we can check the several steps. We can check all those inputs before we are processing uh, that into our program. Similar way it applies to the builder. So we know that we have to define all the mandatory parameters. We cannot skip any of that. And if we skip any of that, or if any of that is conflicting, then that time when we go and commit the feature, we get a error. So maybe let's see some of that. Let's see one of that. Uh, yes, create base view builder or create drawing sheet builder. Okay, so this is a simple example, right? Let's say mm, I comment out some parameters which might be very important for sheet creation. I comment some of the parameters, and then I try to create the sheet. You can see I got the exception. This is again an exception because this is very well within the NX, this operation is happening. And it clearly says that commit is not possible. The drawing sheet template name must at least be one character long. Something is missing, and we got this message. So commit is not possible if there are insufficient inputs. So we can have a try catch here, and we can handle this exception and provide a message to the user that you might have missed providing some important parameter or important input to create the sheet. Please go and check. So that kind of message we can provide to uh, the user, so that instead of getting this purely technical message, he gets something meaningful. Okay, so these are the couple of ways. Uh, Now, couple of more things which are related to uh, avoiding getting into the exception. By now, we see that there is a very important step After you have completed writing your program, you manage to find all those APIs required, you manage to see that your program works. But there can be various situations where your program is being used by user. So you have to see that what can be the scenarios where your program can go wrong, and then you can use either try catch, or you can validate your inputs, validate your program uh, at every step, so that you are ensuring your program is not going wrong. So couple of examples related to that. In this maybe the same example, what we can do is a very simple I check we can do. We have taken session, right? We have also taken work part. Now, what if uh, the work part is not there? It means there is no open document. Then what we can do is we can use if work part is not null, then only execute this entire code. Means I have written everything in this if now. This if will check that work part is not null. If it is null, then there is no meaning providing all those parameters and creating arc, right? So this is how you can go and add the checks at each step in your code. Let's say if I copy, sorry, I was sharing some other window. Now what I have done is I have written this if condition. If work part is not null, means there is a work part, and then uh, there is a work part, then only you go and create the arc. Then there is a meaning of specifying all those inputs and creating arc. But if there is no work part, then there is no meaning executing this journal, right? So this is how we can go and add the checks at every step. Now let's see if I mm, open the this example, the first one, where we have not added that condition for checking radius and angle. Uh, but here, let's say we do not have any active part. We will try to execute this now. You can see this time we have got the system exception. It says that system.null reference exception, object reference not set for the instance of an object. It is similar to object not found. So why it is that? It is on line number 26. Line number 26 is this one. Here we have assigned some value to work part, but there is no work part. So this has become null, I suppose. But we gone ahead and we have defined, specified all those parameters, and we tried to create arc. But when we try to create arc, how we are creating arc? We are creating that arc in a work part. And as this work part is null, that is why we are not uh, able to create the arc. Maybe we can go and try this debugging into the Visual Studio. But uh, as there is no work part, we got this error. We got this message, and this is system related because uh, this is related to object that we are using, which does not have any value or which is null. So that's why we got this message. Now if I do have this check, if work part is not null, then I wanted to execute and create arc. So now if I play this, what will happen? The program is executed, but no error is there because this condition is true and everything is written within this condition. It means that my code is not at all uh, getting executed. So this code block is not at all executed. Okay, so this is how we can handle the exception. So instead of getting into error, we skip doing that step. As there is no work part, there is no meaning creating arc. So better uh, getting better instead of getting into error, we avoid doing that step in our program. So and this is how we can handle it. If condition or anything else which is feasible based on that particular situation, we can do, and based on that we can avoid our program getting into error. Now quickly I can run this code. We will save this into Visual Studio. We'll rebuild this. Attach to the process. Yeah, attach to the process is done. Now let me execute this in MX. Before that, I need the DLL path. Yeah, now I entered into debug mode. Now if I hover my cursor to have the session, so we got the session object. The UI is not required here. In work part, you can see even though I have written the very correct value to this object, the work part is null because there is no active document. And now as work part is null, my if condition is checking that work part is null, and then it is uh, uh, going to the end. Means it is not going to execute this entire code block. So this is how I'm taken care. So if there is no required scenario, required situation there to go and create the object, the object creation will not happen. The arc will not be created, and instead of getting into error, I'm safe. My program is safe. User will not get the object created because it is not possible. But even user is not getting the error message. So this is how we can go and handle the errors. The conclusion for this entire session can be that you must develop the or you must take out time to perform different hands-on activities. Of course, assignments is the first thing that you have to do. If you have missed any, you go and do that. And if you come across any such error messages, then try to find out the root cause for those errors. If you manage to find out the root cause for those errors, then it is possible for you to handle uh, and write some code that will make sure that your code or your program is not going into the errors. Means error are not thrown by your program. So because you have found the root cause, you will able to write some code there and you will able to avoid getting into the errors. If not, then you can use try catch. So this is only thing that you have to do. But again, I'm repeating this. Try catch is only going to help whether your code is going into the situation where you do not have any control. But whatever type of programs that we have written so far, whatever examples we have seen so far, everything is our in our control. Whatever we are creating, any object we are creating, any checks we are performing, any information we are reading out from our objects from our part. So everything is in our control. So there is no external factor involved there. So most of the times you will able to handle it using if condition or something similar, and you can even avoid using try catch. Only try catch is will help you catch that exception, that it is not going to solve the purpose. It is just like bypassing that error. So this is what will happen if you use try catch. There are no much of the ways actually. There are no much of the ways to handle the to avoid the errors. It is actually errors are because of how we have written the code. If we have written the code that is uh, that that does not get trapped into the errors, then there is most there is less likely that we get into the errors, or our program will get into the errors. So it is purely on us how we have written the code, and based on that only uh, uh, it depends on how many number of errors or how many different kind of errors our program is getting. Okay, so I think that's all for today. Nothing else to talk about. It's only the matter of improving uh, your ability to find out the code, and how you can do it is definitely by doing more and more hands-on. So as usual, we'll also have a assignment to do today based on the today's topic. So I will share about that assignment once we finish this session.